Today we're going to talk about two-dimensional motion. That means, in addition to falling, we're going to talk about how things can move sideways when they fall at the same time. And sometimes this is called projectile motion, because sometimes you will want to launch a projectile, something flying through the air sideways, like that. Anyway, so projectile motion. What we're going to learn today is that when something is falling down, it behaves certain laws. And you can really just think about it as falling up and down and ignore its sideways motion. And so the first thing we'll do is show you that. We'll have two balls, and we're going to throw one sideways, and we'll have the other one fall straight down. And projectile motion, the way we understand it, the way we're going to talk about it, is that we can ignore the sideways dimension, side to side. So the up and down motion will be the same, and so if the up and down is the same, they're going to arrive at the floor at the same time. So we'll launch one sideways, we'll let the other one fall down to the ground, and they'll hit the ground at the same time. So now we're going to launch the orange one, and we're going to let the yellow one fall straight down. We'll see what happens. 3, 2, 1. There we go. As we can see, something just flying through the air as a projectile, right, moving straight through the air, is going to fall at the same rate as something that you just let go. So if I shoot this one straight, okay, it's going to fall and hit the ground as fast as this one, and they'll hit the ground at the same time. Now, another fun thing to think about is how do things that look funny, like this long rod, fly through the air? Well, if I take a ball and launch it up in the air at an angle, you know what it looks like. It looks like a parabolic curve. Well, you may not know it's a parabolic curve, but it's a curve, right? It goes up, it slows down, and it comes back down again. All right? Well, if you throw something really ugly like this, it spins and wobbles and everything, does it follow the same path? Well, actually, it does. Its center of mass, the middle of it, okay, according to mass, will travel in that same pretty arc. So I have this ugly long thing, and there's a light on one end and a light in the middle, right about the center of mass here. Okay, it balances right there, so the center of mass. So what happens is, if you watch this light, and I throw this up in the air, this light should obey the nice, pretty little arc. Meanwhile, this light will be whipping all over the place because the thing will be spinning. Right? And that's going to show us that objects travel in that pretty little arc, right, parabolic curve, that matches the center of mass, travels in that cool parabolic arc. So here it goes. I'm going to throw it, and it should go in a parabolic arc. Okay, so now when I throw it, watch the middle light here, the middle one, and it should go in a parabolic curve. Here we go. 3, 2. So there's lots of cool applications to this. For instance, if you had a space station, right? First of all, center mass is cool because things spin around their center mass. But a space station is technically falling, right, as we learned a long time ago. And so it's going to fall like the center of mass of that space station is going to fall. So there's a lot of cool applications. But things that are irregularly shaped fall and have that same projectile motion. It's just sometimes hard to see because you get distracted by all the gangly long parts here. And it really all falls in that nice arc if you just look at their center mass.